I wouldn't say that the answer is too clear cut when it comes to this whole notion of what framework or engine should I use to render my graphics. So, for example, if you want to go the 2D route, there's some very powerful libraries courtesy of Direct 2D, as you're going to see in this particular video, utilizing the SlimDX framework, which is a managed C Sharp wrapper for DirectX. And there are also many other libraries, APIs, engines, and frameworks you can use to develop 2D and 3D engines. So in this particular video, what I want to do is to actually go through not only how to render a window on the screen, but how to use the SlimDX library with C Sharp managed code in order to harness the power of DirectX. I already made a video regarding loading a window, and this is going to cover that topic a little bit because I think that with this revised lesson, it's a lot more clearer as to how the process is, and you guys should hopefully benefit from that. My name is Will. Welcome to the channel. Welcome to the video. Without much further ado, let us proceed with this video. So on the screen, you should be able to see a very simple piece of geometry. It's a blue rectangle with a red outline, and there's a black window. Now the thing is, this may seem, and for all the right reasons, this may just seem like a rectangle on the screen, no big deal. But when it comes to diving deeper into how graphics are generated, and if you do want to take the time to learn on a lower level how to generate graphics using a framework such as DirectX, then it should come as no surprise that even to make the most rudimentary of geometry, 2D or 3D even more so, takes quite a considerable amount of time. Therefore, I find it very useful to have access to manage C sharp wrappers like SlimDX, and also you have the Sharp DX option. I've not really used SharpDX personally, but I've heard good things about it. But this is going to cover SlimDX. So we'll do just a little bit of housekeeping before I get into how this process came to be. I'm just going to go ahead and close this window, and just some resources that you may want to be aware of that will help you a lot. So the book that I actually referenced, the majority of my learning for this particular topic was Game Development with SlimDX by this gentleman here. And the thing is, I don't want to say his name wrong, Michael Fontanini. Hopefully I said that right. And as you can see, this book has been around since 2013, original publication, and it's just a really good primer into the subject. The examples are clear, and so I do encourage anyone who is considering using SlimDX. I'm basically reading it on Scribd, which is a website. I'll leave a link in the description. I'm not affiliated or anything like that. I just think it's a really good resource. So I'll leave a link to the website where I'm reading the book. Otherwise, you can just find it somewhere else. If there is somewhere else you can find it, I'm not too sure. I use MSDN for some of my background research. MSDN is a very amazing resource of Microsoft-based information for their languages such as C Sharp, Visual Basic, and also stuff like C++. And in this particular case, I used MSDN to just kind of brush up on some of my background knowledge and some more intermediate concepts that are kind of needed if you want to really utilize the power of the SlimDX library. We're going to go over that. And I do hope to make a written version of this particular tutorial on my website. So I do have at the moment a courses section with just a couple articles. I think there's just one. No, okay, so there's two that are actually published, and I do hope to add a written version of this to some capacity. So do stay tuned in terms of this. If you do want to read up on a written article, if you prefer that, hopefully not too long after the release of this particular video, there should be some material there for you. So with all that out of the way, I think it's a good time for us to just dive straight into the code. So I'm using Visual Studio 2017 because that is the version of SlimDX that works with Visual Studio for me, at least. There may be ways you can tweak your IDE.NET target if you want the SlimDX library to work with 2019. I didn't really find a way around that, so I'm just using the 2017 edition, and it's quite sufficient for my needs. You're gonna need a bunch of namespaces. So heads up, SlimDX is on Nougat. So just go to Tools, your Nougat Package Solution Manager. Import the SlimDX library. I won't show the whole process because just for the sake of time. But once you've done that, that's the only third-party namespace you're gonna really need to import. The rest is gonna be from Microsoft system, basically .NET namespaces. So let's just get straight into this. So the way I did this, there is so many ways you can go about making a framework for a 2D game. And just to let you know, this is going to be for 2D. Let's just walk before we can run, as I was telling myself, to be really honest. So I'm going to start with 2D, and then as time goes, 3D should be on the cards most hopefully. So anyway, so we're going to we're going to draw a 2D geometry on the screen. So I started, and I really do hope my computer keeps up with me here. Just to give you an idea, if you go to File, New, and opt for a new project once your Visual Studio loads up, what you should do, at least for me, I'm targeting a Windows desktop, and it's an empty project, .NET Framework. I think it's .NET Framework. I'm not too sure, because I think there's .NET as well. But to be on the safe side, I would start with .NET Framework, because I think this version has the least amount of friction with the SlimDX library. So we'll go ahead and start an empty project. Let me just quickly check this one. No, okay, so if I'm wrong on that, then it should be the .NET version, if there is one. If not, it will just be .NET Framework. Maybe that's the only version, I'm not too sure. Once that's there, you'll be met with an empty class. I went and gave this the name main game window, and this is the main class that will contain a main function that will have our entry point for the actual whole application of the game. So once you basically have this class made up, once you make a new project, go ahead and add a main function, a static void main. And this is, as I said, is going to be the main entry point of your application. And just for good measure, you can also right click on the project and just make sure that you're setting this as startup project, because we start with basically an empty C# file, basically. So you want to just make sure you're targeting the right project as startup. So set as startup project. So I'm going to just go up, and once that's all sorted, we're going to need a bunch of variables. And this tutorial might be a little bit out of time, because the thing is, I'm going to go back and forth most likely, only because I'm not typing it out in real time, because I've already done it and that will just take a lot longer. So I just figure I will explain what I've already done. So I'll try my best to explain everything at a brisk pace. So we have here some variables. We have booleans for checks. So we have is disposed, is initialized, M is full screen, M is paused. And just as a heads up, these pertain towards the screen device. So the device, basically, the screen. So in case you weren't aware, every time we deal with DirectX, we have to initialize something called a device. And what a device is, it describes what the display is. So for example, if you're there dual screening on your gaming rig, somewhere, playing your game, somewhere down the line, there's source code that is initializing your system device, and that will pertain towards the monitors on your screen. So more often than not, I'm pretty sure anyone who works at a lower level, like for example with DirectX, building a framework using DirectX, will have to always take into account what sort of screen resolution is being used by the gamer. The things we take for granted as gamers. Dual screening, how many screens are gonna be used at once? Can the window support resize, and such and so forth. I took the liberty of setting some preset values, which obviously, if you were to ship a framework or a game, you want to be a little bit more flexible than a lot of games I have seen, especially in the past, will just have presets, and you as the gamer will choose. So if you remember like some of the older games on PC, you have like maybe a variety of preset for resolutions, and you can only play the game on those resolutions to have like a guaranteed kind of like full viewport experience. Otherwise you might get clipping, black bars and such like that. It's a little bit more tricky than it seems in terms of like adaptive responsive UI, especially when you're rendering 3D geometry at real time with a full-on framework. So for now, I have just 480 for the width and 256 for the height. These variables are with regards to the dimensions of the window, and I have the rest of these variables here. I'm not going to go through every single one. As we see them in the functions, I should hopefully have time to explain them. And probably in a different video, because I haven't actually program functionality with regards to controller input, but I do have a class called controller dispatch, and I do have full functionality ready in terms of actually parsing controller input. And this I got from my previous project that I wrote. It's a Win32 game that I wrote, that I'm still kind of writing, I suppose, in that sense, because it's not exactly complete. But the controller parsing functionality is all there. So I want to make a separate video for this because it's another video in its own right. It's quite fascinating as well. So that will be quite fun. So I separated everything to do with controller parsing in a separate class called controller dispatch. So that's over there. Okay, and the way I approach this is that yes, so we have a window render target, and we have a factory, which basically helps us to, if I'm not mistaken, create our device, to initialize our device. And we have solid color brush, and this just defines a particular color of a alpha RGB value. So this will represent for R, G, and B. And we also have, this is another class called game window D2D. I'm going to go into this when we reach that part of the bridge. I don't want to confuse you just yet because we have to still deal with what's going on in this class. But this is also quite an important class. And just to give you a heads up, it's to do with rendering the window at game time. So I have this functionality here, this class, but it's not constructed yet. And I have a couple properties here just for Dispose and Initialized. And this just basically for Dispose. So when we're dealing with resources, especially in the unmanaged space, even though we're dealing with like C# wrappers, in this kind of paradigm, we have the garbage collector. So us as .NET C# developers, we don't have to worry too much about memory management, but it is something to take into consideration and account. What we do is that we release our resources, but there's a flag, which I have here, just to indicate in the program when that time should be. And this basically is a flag which I use to initialize particular resources. And once it's initialized, there's no need to initialize again. So the flag is therefore set to true, and then I evaluate it for false, and thus I fall through because it won't actually step. So that's what this is for. And let's just go down. So here's my entry points into the class. And you want to go through application. So I think this is a system namespace. So it's a system class, system Windows Forms applications, and you have all sorts of members with regards to managing an application. And the function you want to pull from this is enable visual styles. And you want to also, from the same class, you want to call this function set compatible text rendering default. And you want to pass an overload of false to that one. And then let's start by constructing the game window. So this particular class, the main game window, we're going to construct it in our entry point. And we are going to, if I just go to the constructor of this class, which is down here actually, excuse me for that, what we'll see is that we are expecting some items in the overload, some parameters to pass. So we have a string title, width, height, and full screen as a bool indicator. And so when we construct our main window, we'll pass into the constructor the main window title. I'll go to the definition. And that's just basically a string, SDX D2D. So that's the name of the title of the window. For some reason, I didn't see it on the window itself when I was running the game. I'm not too sure why it didn't come up. Maybe there's something I missed or something. But I might have to look into that for the next tutorial. But it's not too important. But it's still something that should be corrected on my part there, so just a little apology there. And I set the dimensions of the window. I actually feel that the window is a little bit too small, so I'm just gonna go ahead and change this. I'm gonna just quickly change it to 1080 by 720. And yeah, so where was I? Okay, so I have a global here, a global variable, and this global variable is M is full screen, and this is past the it's just a global reference to this particular parameter, which I pass as a false initially. And clear color is a color full struct, and I pass an alpha value of 1, but the RGB values are 0. But we're going to need this a little bit later, so we'll just keep it here. We'll just keep it constructed. And then I have initialized the game window. So for this, I call render form, which is a variable that I declared at the top here. So I'll go back. And I'm constructing the render form class. And then I'm calling the client size property in the render form, and I'm giving it a value, which is a new system.size. And I think that's, yeah, it's a function, not a struct. I thought it was a struct. It's a function called size, and I'm passing the width and height of the window. And I'm setting up an event. And this particular event is the form closed event. And so every time the form closes, the window itself, then this event fires, and I have a function here, form closed, which is hooked to the event. And what this basically does, it disposes of, it calls dispose. So it basically releases the resources. But what this does, I've actually got a function, a virtual void function. And because I'm actually overriding this in another class, that's why its keyword is virtual keyword before void. And because I'm going to be using this in another, I'm calling this functionality in a different class, so we will get to that. And I'm just calling dispose here, gc.suppress, and I have a throw not implemented exception there. So what you want to do, just to make sure that this dispose functionality works, if we scroll to the constructor, or rather not the constructor, but where I'm declaring the class, I want to inherit from the iDisposable interface. I hope the terminology is correct there, inheriting from this basically from this particular interface, which means I can access members of the iDisposable interface. This particular interface allows me to access particular members that only this interface gives me access to. And it's quite a commonly used interface in different programs. You've probably seen it if you've or at least know about it if you've written .NET C# for a while. So you want to go ahead and implement this interface, and that gives you access to particular functionality with regards to disposing. So I'll just scroll. We have basically set the members with regards to the window. We've set some basic parameters, and we've constructed our main class through an entry point into the program. So now that we've done that, what you want to do is we want to focus a little bit on some of the looping. So here I have a function called GameLoop, and this could be in a separate class, and depending on how you look at things. For now, I just kept it in the same class just to keep things a little bit simple. And in the game loop, we take our variable last frame, and we are assigning it the value of current frame. And mind you, if I just quickly hover over this, it's a long. And so what this does, the frame represents what frame is on the screen. And we have an update function, which I'll quickly snap to now, which is a public virtual void update. Again, we're overriding this function in another class, which I will show as we get there. And so this update function isn't doing much, but you can have it ready anyway. So it's actually supposed to be dealing with the controller logic, but right now the render logic is elsewhere. So we don't have to worry about the contents of this. We're just going to keep it up so we don't get any errors. So you want to pass the necessary overloads. So update, we're casting basically this calculation from the offset between the current and the last frame and the frequency to give us, ultimately, we are looking to get our frames per second. And the frame time, you want to pass that into this parameter, as I've named here frame time. And we call this function called render scene. And we also track the frame rate, which I have here. So you want to just make sure you're doing that. I'll just go ahead to render scene, which is all still in the same class. And initialize, if the resources are not ready, then just return the function because we're not ready to actually render. But once our resources are ready, and things are initialized, then we can go ahead, and what I've done is I decided to construct a separate class with some of the draw functionality, and this is called game window D2D. So it's another function. Sorry, no, it's another class. I'll go to that in a second. And as you can see in the constructor of this class, it accepts a string window title. It accepts an int window width and also an int window height and false as well. So let's hop to this and have a look at what's going on. But before we do that, I'm just going to scroll down to start game loop. And with StartGameLoop, the functionality is, as you see, it's doing a quick check, and this is basically what I placed in here was the functionality for the message pump, so that the window can be indefinitely on the screen via this message pump.run function. And so if the resources are initialized in this particular case, then we return, because we actually want to initialize this message pump when we haven't initialized, if that makes sense. So this is actually initializer logic, because if the resources are not initialized, then we go to run the message pump. And once the resources are ready, then we just return. And then once the frame is discarded, once we release our resources, then of course we want to run message pump again. Okay, so now let us go into this second class. The game window D2D is over here in my solution hierarchy. So I'll just double click it. And so what's going on here is that game window D2D, sorry, is essentially the same class in a sense. I won't use the word the same, but it inherits from the main game window class, the class I just took you through. So it has access to members of the game window class, and I also I'm inheriting from the iDisposable interface. So I have access to members of the iDisposable interface. This is for the second class, game window D2D. And if we just scroll down, we want to declare some variables once again. I have global declarations for RGB values, which I've named accordingly, and geometry, and also a render target. So it's just here. And this is the constructor for the class. So I have public game window D2D, and I'm passing as I have some overloads here. So it takes a string int boolean to define whether I'm in full screen or not. And then here I'm calling base. And now I can put up the documentation, or I can just really quickly go over what base allows us to do. So all it does is that. So base allows us to access members from a derived class. So this gives us access essentially to the members of main game window. So, but the thing is, you have to pass the same signature as main game window. I'm gonna just quickly verify that. So let's just go and see the constructor of main game window. As we can see, main game window in the constructor takes string, basically string, int, and boolean. And I don't think the name matters too much for these variables, but it's the types that you're passing. The overload matters. So if I go back, the signature is basically defined by the overloads that you pass. So title, width, height, and full screen. And these are essentially the same types that you just saw in the constructor for the main game window. So we're going to make sure that matches, or it's not going to work. Now let's get into the contents of our class. And we have here mFactory. Now, as you can probably tell, I don't have mFactory declared anywhere here, but that's where the inheritance comes into play, because now we have access to mFactory, and hopefully you can see in the IntelliSense it's quite small, but on inside the main game window class, mFactory is a member. So we want to go and instantiate that. And we want to create this window render target properties and instantiate this class. Now, I went ahead and I was experimenting, so I had a try catch. And this didn't work at first, because what I was trying to do is I was trying to access the handle from the main game window class, but this approach didn't work because I needed to get the dimensions from the initial window. because I kind of segmented the code so that the draw logic is in a separate class to the actual game initialization logic sort of stuff. So basically, what I ended up doing was that I used the base keyword so that I can access this variable, which I defined in the main game window called render form. And let me just go to the declaration actually, just so we can keep up with things. And if I can find all references, and I'll have a quick look. So we're in the main game window class and the render form is being instantiated. So this is where we instantiate the render form, just in case you were wondering. I'll go back. So in the game D2D, so I'll just say D2T for now. So in the D2D class, we have that same member and we're accessing the handle property. I think it's a property. Yeah, it's a property. Handle property. And we're passing it into properties.handle. And then properties, we're accessing the property of properties, pixel size. And we are just constructing a new size struct. And we're passing the width and height parameters as well. It's actually not a struct, it's a function. Sorry about that. And window render target, we're constructing this member here. Window render target, again from the main class. Let me double check that. No, sorry, I was wrong. This is actually, where do we start with this? It's in global scope in the D2D class, so that's over here. So the reason I had to try catch, because I was just thinking to myself, wow, trying to figure out why am I getting an exception, and it was because I couldn't properly access the handle. It can be a little bit tricky dealing with window handles, so I just had this little workaround. And then now I'm instantiating the RGB solid color brush objects, and this is where the coloring and the drawing start to come into play. So if I just scroll slightly, I have these members again from the main window class, and I'm just instantiating them. So I'm passing into the constructor the window render target, and I'm just defining the colors for each. So I think it's RGB, and as you can see, the alpha value here, the first parameters are alpha values, if I'm not mistaken. Yeah, so alpha is 1, and depending on RGB, I have different values for RGB for red, green, and blue. So that's that. And then now the path specifies the path of which you want to draw on the screen. And so this geometry variable, I'm constructing it, I'm instantiating it, and I'm passing into the constructor the factory, which is a property from the window render target. And now I use the using. And using is always a good shout when you're dealing with resources that have to be released once they're done with. So once you have a using block, then you can go ahead and you can do geometry sync, create a variable, and you assign it mgeometry.open. So this is a function which you'll find in the path geometry class. And then we're basically defining some bounds for our drawing. So I believe this is measured. So basically, I'm measuring the bounds or kind of like the dimensions of the rectangle based on the window height, like offsets derived from the window height. And as you can see, the arithmetic, very simple arithmetic is here. And you want to define also instantiate these point f structs. And you want to pass the appropriate top, left, right, and bottom variables into the structs. So I'll let you have a look. It's just over here. And then geometry sync. From the geometry sync class, you call begin figure, add line, end figure. And this is quite important for the drawing as well. So you want to definitely make sure you have some kind of functionality such as this. And I'm calling render scene at the end. And I'll just quickly hop to render scene, which is a function in D2D in the game window D2T class. So the same class, and the render scene basically draws everything according to our defined functionality. So it does an initialization check once again, and if things are initialized, we return. If not, then we begin to draw. And the flow for drawing is just like this. So begin draw, we call clear, we fill the geometry, draw the geometry, and we end the draw. and this is just looped over and over and over again. And here I'm calling the overridden render scene function, so via the base keyword, so that's over there. And again, we want to have a dispose implementation here as well, just like we did in the first class. And so if you follow this guide more or less, then you should hopefully have a shape, a geometry on the screen, a shape on the screen basically. So if things are not too slow, I'm just going to run the program one more time. I did change the dimensions from like 480 by 260, I can't remember exactly, to like 720 height and like 1080 width. So as soon as that's loaded, we'll be able to see a screen. So what has happened, this kind of terminal window comes up first, so just so you can see, but then the actual DirectX window should come up as well. The output window is just some activity there. And just off screen, I'll drag it here. Here is the square. Now, this is not optimized code at all by any stretch of the imagination. So when I did actually cancel this before, I had to pause because I was getting like an exception, and the debug session was interrupted. It couldn't load the symbols, which probably has something to do with the basically the way I utilized maybe the unmanaged functionalities. So there was some symbol loading stuff I had to kind of take into account. But maybe actually going into project and going into the properties, because you can actually set unmanaged and managed debugging basically. And so yeah, as you can see, I'm getting exceptions because I'm not really dealing with my members very well. But the main thing I wanted to show you guys was the fact that you can get started with SlimDX drawing very primitive, very simple primitives on the screen. And again, I disclaim I have not utilized this framework to the point right now that it's completely optimized. So just bear that in mind. But I really do hope that you may get some value into how this is done. So yeah, I'm gonna definitely be continuing in terms of digging a little bit more into SlimDX. My previous video was just how to generate a window. This goes one step further, how to generate some kind of geometry on the screen. And as we go, hopefully there'll be some more videos taking step by step through the topic of SlimDX. From 2D, I want to actually go into bitmap loading, so you can have like sprites on the screen, and then hopefully we'll get onto 3D. So thanks very much for watching. My name is Will, and do stay tuned to the channel. Please subscribe, drop a like, if you do want to kind of like keep up with what's going on in the channel. I really do enjoy going through 2D and 3D games design, anything from, C#.net, from payment solutions, bots, and video games design and development. So I will bid you a good day. God bless and have a great day, everybody. Happy New Year once again. Bye-bye.